Dilutions or dilutions. This is a process that you do almost on an everyday basis. If you drink coffee in the morning and it's too strong and you don't like to add cream, then you would add more water to it. You dilute it. If something is too sweet, like a sugary drink, a solution, you can add more water to it. You can take a little bit of it and then add more water to that. You dilute it. It happens all the time. So the question is, in chemistry, how do we use it? Well, we use it, of course, in relation to solutions and what kind of solutions we need to prepare. So you need to remember that there are two types of solutions. You have what we call a diluted, less concentrated solutions, and concentrated solutions. So there's, of course, more and less. In chemistry, you use diluted solutions a lot, especially with acids, because acids dissolve pretty much, all biological material. Of course, it depends on what application. But if you look here at the diluted versus the concentrated solution, you'll see that the difference is in how much solute they have. So in this one right here, this is a concentrated solution, solution A. You see that you have a lot of solute solutions, solute particles in relation to the solvent particles. That's why it's that color, right? This darker color. Whereas if you have solution B, it's a dilute solution or dilute solution. You have a lot less solute particles in relation to the solvent particles, to water, let's say. So that's how you should think of it. You should think of it that way. Is that less solute in more in diluted solutions than in concentrated solutions. The equation is the following. M sub C, V sub C equals M sub D, V sub D. So this refers to the concentrated, and this one refers to the dilute or diluted solution, the C and the D. The M stands for molarity. That's how we measure the concentration. V is volume. M, again, V is volume. Your book, or sometimes it's, usually this is written as MIVI, meaning initial, equals MF VF, meaning final. Yeah, so you can start with the concentrated as your initial. And again, so we'll write this down here. Initial. And this is final. Similarly, it's sometimes it's written as M1 V1 equals M2 V2. All of these pretty much the same thing. Sometimes C1 V1 equals C2 V2 in concentration. So it's all pretty much the same. Again, here's a simple problem. The problems can become more involved. But this question is asking you, how many liters of a 6 molar HNO3 nitric acid solution are required to make 4 liters of a 0.5 molar nitric acid solution? Now, the key to doing this problem correctly is reading the question very, very carefully. It says, how many liters of a 6 molar HNO solution? You need to make 4 liters of a 0.5. So right away, the 6 and the 0.5 molar should tell you that this one has more solute in it. So this should be your MC. This one has less solute in it, is 0.5, so that should be your MD. That's the concentration of the diluted solution. Meaning, again, this means you have 0.5 moles of HNO3 per 1 liter. This one says you've got 6 moles of HNO3 per 1 liter. And of course, you need to make 4 liters of this dilute solution. So this is V sub D. So what are we looking for? What's left out of this is, of course, V sub C. It says to you how many liters of this concentrated solution do you need. So we write our equation, M sub C, V sub C equals M sub D, V sub D. And of course, we need to solve for what's unknown. So our X here is V sub C. So in math, you probably know what we had to do with this. Is we would have to isolate V sub C, so we would divide each side by MC. So of course they cancel out on this side, and then you're left with V sub C equals M sub D times V sub D over M sub C. All you have to do now is plug in. So M sub D is 0.5 times 4 liters divided by 6 molar. So you're multiplying, but again, the units cancel out. So in this case, we take the 0.5 times the 4 divided by the 6. So that's 2 over 6, which of course, since we need 1 sig fig, because that one has the least sig figs, we just report this as 0.3 liters. That's what's left. So imagine you just need 300 mils or 0.3 liters to make a 4 liter solution. It's just shows you how much more concentrated this solution is, the 6 molar to the 0.5. Very well. So again, those problems can be more involved. So make sure you practice and do enough of these. They can ask you to actually calculate the grams of one of the, or how much grams to start with, etc. That's it.